This is concept 37. In this one we cover the geometric features and properties of rectangles. Rectangles have the same properties of parallelograms, so just take a moment, pause this video, and reread the 5 properties of parallelograms. So it's those 5 properties plus these. There's 2 more. They are all 4 angles are right angles in the rectangle, and 2 diagonals are congruent. And what do I mean by diagonals? Those are the lines that we can draw from one corner of a rectangle to the other corner, to the opposite corner. So in this case they are equal. So number 1, we have each quadrilateral below is a rectangle. Find the missing measures. So we need to find QR. QR is right here. PS is 10. The 2 opposite sides here are clearly the same, so that one's 10. QR is 10. SR is the bottom side here. The top side is 24, and of course the bottom one must also be 24. So let's label it there too. SQ is this one here. Okay, so it's a diagonal. Okay, and if we, let me use red here, we can probably see that once I trace it, we have a triangle, and specifically a right triangle. And why is that? Because we know, okay, based on one of the properties, that all 4 angles are right angles, so this one here is a right angle. So we are taking that skill from a previous concept we've already covered to find what SQ is. We have 10 squared, that's one leg of the triangle, plus 24 squared, the bottom leg of the triangle, is equal to SQ. SQ would be C. So 10 squared is 100. 24 squared is 576. That's equal to SQ. 100. Whoops, and I forgot SQ squared, right? A squared plus, let me move this up. A squared plus B squared is equal to C squared. Okay, so don't forget to write the squares in. So then 100 plus 576, that's 676. That's equal to SQ. And then if you don't remember, the way we cancel out the square, because we don't want SQ squared, we want just the SQ, you would take the square root of both sides. Okay, so the square root and the exponent here cancel, and then use your calculator and figure out what this is. Okay, so you take the square root of 676 and you get 26. So SQ is equal to 26. Let me use red to write it in. That way it's easier to see in our picture here. PR is the other diagonal. Well, we know from our properties here that diagonals are congruent. So if SQ is 26, the other one is also 26. So I'm done there. QT is here's Q, here's T. Okay, QT is half a diagonal. So what you do is just take the measure of the entire one and divide it by 2, and you get 13. And I'm done there. Number 2, same idea. I'm finding the missing lengths of measures missing lengths of sides. So AC is a diagonal here. Okay, I have one diagonal 15. Okay, half a diagonal 15. That's AE. So then the entire thing would be double this length, or 30. BD is the other diagonal, and this time is the entire thing. So we know that AC was 30, and we know that diagonals are congruent, so the other one is also 30. BE is the other half diagonal. It has to be, of course, the same one as this one, so we have 15. AB is the top length here of the rectangle, the bottom is 27, so the top one is also 27. And then BC, that would be this side here. Okay, now let me write the top one here. How would I go about finding this length? What we're using, and let me trace it again in red. We're going to be using the Pythagorean theorem again, and I'm going to write 30 here because we know that BD is 30. So I'm going to use the Pythagorean theorem to find this missing length BC. Now remember that C, and what I'm talking about here is we have a squared plus b squared is equal to c squared. C is always going to be the side that's opposite to the right angle. Okay, unlike the previous question where I needed to find this one, in this case I am missing one of the lengths of the triangle, one of the legs. Okay, so in other words, B is missing, C is given. In this previous problem I had to find C. Okay, so I plug in 27 squared plus BC, that's B, okay, that would be B in my formula. BC is the missing one. BC squared is equal to C squared, which is DB, 30 squared. So 27 squared is equal to 729. 729 plus BC squared is equal to 900, that's 30 squared. And then you do I'm solving for BC squared, so subtract 729 from both sides. I'm not going to write it out because I'm running out of space here. So BC squared is equal to 900 minus 729, and you get 171. Okay, now 171 is not a perfect square. From here you would take the square root of both sides. Okay, the square and the square root cancel here on the left side, and then I would take the square root of 171, if you can see this, and no, it's hard to see, but you'd see that it's not a perfect square. You get 13.0766. So I'm going to round this to, we could say 13.1. So BC is equal to 13.1. And that's it, I'm done. From here on out, so that the video doesn't get overwhelmingly long, I would recommend that you check out at the very least every odd number problem. I'm going to continue doing all of them, but at the very least, okay, check out the odd number problems. Number 3, this time instead of finding lengths of sides, I'm finding measure of angles. Okay, number 3, I need MJK. MJK is right here. Okay, the entire angle here. We know that all 4 angles are right angles, so this time it's asking for one entire corner, so it is going to be 90 degrees. Next one says MJL. MJL is, let's see if you can see here, M, J, and then L. Okay, well, I know part of this entire right angle being 90 degrees, okay, is 27. MJK is 27 degrees, plus this unknown here, they need to equal 90 degrees. So if I do 90 degrees minus 27 degrees, that's going to give me this angle here. Okay, and I get 63 degrees. That's MJL. So this one is 63 degrees. And again, you check your work because they need to add up to 90. Next one, measure of JLK. Here's JLK. Now, the way you would look at this is similar to our parallelograms concept, where if you extend the top length here as if it was a line just going on forever, and then same for the bottom, okay, and you treat JL as your transversal between 2 parallel lines, okay, you'll see that 63 degrees, this one, MJL, is an alternate interior angle to JLK. So this one is also 63 degrees, their alternate interior. KML. Here's K, here's M, here's L. Okay, angle can be a little tricky to understand, but this one takes from our concept on properties of isosceles triangles. Okay, so maybe we should label this one also 27 degrees, because if we take the same idea, this can be seen as a transversal to these two lines here. So then these two are alternate interior angles. Okay, now you could just go ahead and try and generalize all around what each angle would match to these two, because we have a rectangle, so they need to match. But how do you know which is which? So if you look at this as properties of isosceles triangles, and I'm looking at triangle MNL, okay, we already know that the diagonals, okay, the diagonals are congruent. So each half of each diagonal also is the same. So this side here, this side corresponds to that side. Those two are the same. Okay, they're equal. So if this side is, or this side relates to 27 degrees, this side also relates to 27 degrees. Hopefully this is familiar. And then in the same sense, okay, you can say, because these two triangles here, okay, so I'm looking at triangle JKN up here. This side is opposite to this one. This side is opposite to this one. So then this one is also 27 degrees. And then you can go ahead and label now the rest based on what we've already labeled right now. Okay, so KML, here's KML, we already know it's 27 degrees. And then MNL, here's MNL. Okay, that's this center angle here. How do we figure what that is? So looking at triangle MNL, okay, we know that the interior angles of all triangles add up to 180. We have the two base angles here, 27, 27. So 180 minus 27 minus 27, okay, gives you, let's see if I can do this here. Okay, 180 minus 27 minus 27, I get 126. So angle MNL, it's 126. And I won't try and squeeze it there because it's already tight. Number 4, I'm finding measures of angles X, Y, X, W, Y. Here's X, W, Y. We have this angle here. We can think of it as properties of isosceles triangles again. Why? Because again the diagonals are congruent, and if you cut the diagonals in half, you're gonna have 4 equal parts. Okay, and then if you just think of it, I know the triangle is backwards, but if these two sides are the same, this side and this side, then these two angles, the opposite sides, the opposite angle, sorry, to the sides are also equal. You know, this one is 64, and then these two are equal. Okay, so you can call this one X, X, 64. They all add up to 180 degrees. So 180 degrees, 180 minus 64, okay, 180 degrees minus 64 degrees is equal to 116. 116 degrees is split between this one, and this one. So 2x is equal to 116 degrees. So divide this one by 2. Okay, so then divided by 2, 116 divided by 2 is equal to 58. So x is equal to 58 degrees. This one here is 58, and that one is also 58. Not to confuse you guys with this setup here. Okay, so what I did was, just to show you the actual expression, it was 64 degrees plus x is equal to 180. Okay, and you can go ahead and solve this one, and then you'll see that it's the same setup that I got here. Okay, moving on, measure of y, x, z. Here's y, there's x, here's z, so it's this one here. Okay, we know that all corners or angles here in the rectangle are 90 degrees. We have part of it as 58. The rest, the little angle here that I'm pointing at, plus this one need to add up to 90. They're complementary. So subtract from 90, 58 from 90, you find this one there. So 90 minus 58 is 32. So then this one is 32. WVZ is WVZ right here, WVZ. Okay, there's a few ways you could look at this one. One way would be that you have a straight line here, so then you know that, I'm drawing it in blue, this here is a straight line, so they need to add up to 180 degrees. You have part of it as 64, so 180 minus 64 gives you 116. So then this one is 116 degrees, and again it's a straight line, so 116 plus 64 needs to equal to 180. So this one is 116 degrees. Next one, XWZ. XWZ, that's the entire corner, and we know that the corner needs to be a right angle, so this one's easy, it's just 90 degrees. And then XZY, XZY is this one here. Okay, let's see, one way you could look at it is you can try and match it. Actually, let's look at it this way. Properties of isosceles triangles, just match it to the top triangle, because these two would have to be similar if two of the sides are equal with each other. Okay, so then these are clearly the base angles up here, okay, of this isosceles triangle. So then this one also shares the same equal measure base angles, this one and this one. So these two are 58 degrees. So then XZY is 58. Whoops. 58 degrees. And I'm done. Number 5, it says, given that DB is 42, DB, let's see, DB is the entire diagonal here. Let me use red, okay? Red for DB. The entire thing is 42. AD is one of the side lengths here, 26. And then the measure of DAE is 52. DAE is 52. So that's 52 degrees. Find the rest. So AC is the other diagonal. We know that one is 42 degrees. We know the diagonals are equal, so this one is also 42. I think I said 42 degrees, just 42, sorry. EB is half a diagonal, so divide 42 by half, by 2, you get 21. BC is the other opposite length side of this rectangle. If one is 26, the other one is clearly also 26. AB, the top side here, okay, what we will need to do is, let me trace it in red. Okay, we are looking at this triangle here, so we're using the Pythagorean theorem again. One leg is 26. Here's my right angle, okay, in the corner there. Here is my arrow going toward C. Okay, so C is given. C is 42. A is 26. I am finding B. That's my missing one. Okay, so 26 squared plus AB squared, that's my B, is equal to C squared. C squared is DB, 42 squared. Now use your calculators. Okay, you'll do I'll show all the steps here. So 26 squared is 676 plus AB is equal to 42 squared. 42 squared is 1764. Subtract 776 from both sides because I'm solving for AB. Whoops, forgot squared there. Okay, I'm solving for AB squared. I get AB squared is equal to 1088. Then here you take the square root of both sides. The exponent and the square root cancel, and I get AB is equal to square root of 1088. That's equal to 32.98. And if you round, you could just say 33. So then AB here is 33. The measure of ADC, measure of ADC, okay, that's the entire corner of a rectangle. We know that's 90 degrees. ABD, that's this angle here. Okay, let's use properties of isosceles triangles. Okay, let me carefully show here. I am looking at this triangle here. Okay, ABE. This side is equal to this side because we know that diagonals are equal, so half of each diagonal will also be equal. Okay, we can find the measure of this angle here that I'm pointing at. Okay, because if this one's 52 and this was unknown but combined they equal 90, I could do 90 minus 52. 90 minus 52 is 38. Okay, so then this one here is 38 degrees. And again, properties of isosceles triangles, the two legs here are equal, so then the base angles are also going to be equal. So then this one is also 38 degrees. Okay, and then that's ABD. BCA is this one here. Okay, and then maybe before I go and try and figure this one out, let's go ahead and label this one also 52 degrees because they need to add up 90 and they match up this one here. Okay, and then if you look at it, let's just try to use similarity here. This triangle here, okay, this top one is similar to this one here. Okay, so then we can label the angles accordingly. These two are 38, so then these here are also 38 degrees, so then therefore these here are 52 degrees. And you might have noticed that this triangle here is also similar to this one here, and the base angles of each of these are 52 degrees, so these are also isosceles triangles. BCA is 52, and DEC is this the vertex angle of this isosceles triangle. I could do 180 minus 38 minus 38 to find this one. So 180 minus 38 minus 38, I get 104. So then this one here is 104 degrees. And that wraps up this example. Next one, I have these are algebraic expressions. So it says find EF. EF is this one here. It says find the length. Okay, so that means I need to solve for x and then I need to go in and plug in. Okay, it's a rectangle, the top and the bottom are equal, so my expression is 3x plus 5 is equal to 7x minus 39. I'm gonna get my x's on one side. I have, let's see, I'm gonna subtract 3x there. I get 5 is equal to 4x minus 39. I'm going to add 39 to both sides. Don't lose track of your signs, okay? And I get 44 is equal to 4x. If I divide by 4 here, I get that x is equal to 11. I'm not done, okay? So now I need to plug in. I get 7 times 11 minus 39, 77, whoops, 77 minus 39 is equal to 38. So then EF is equal to 38. And that's my final answer. Number 7 says if RT is 5x minus 14, and that's this diagonal here, and US is 2x plus 10, that's that one there. It says find VT. VT is half a diagonal here. Okay, now there's let's see, there's a few ways you can go about this one. Okay, maybe you could pause the video, try it out first, and see what you get for your final answer, and then check with this one. One way I'm going to just go about and do this one is RT, okay, is the entire thing is 5x minus 14. 5x minus 14. VT is half the diagonal, okay? So then I could just divide by, I could just divide one side by half, okay? And yeah, I could just divide, so I could do 1/2 times 5x minus 14, and then go about and find, yeah, I could go about and find my x. Now I'm actually gonna pause this approach. You could go about and do it this way, but what happens is when I distribute the half in, I'm gonna get a fraction, and I don't want to deal with those, so maybe there's an easier way. Okay, so let's just draw a line and let's do the other approach. So RT is this one, US is this one. Okay, so we can set those equal to each other because diagonals are equal, and this setup avoids any fractions, so this is probably the best way to go about it. And I get 3x minus 14 is equal to 10. Add 14 to both sides, and I get 3x is equal to 24. If I divide by, whoops, if I divide by 3, I get x is equal to 8. I'm not done. It says find VT. Okay, so I can plug into either of these because they're both represent the diagonal. I'm gonna plug into RT because we're talking about VT. So RT is equal to 5 times 8 minus 14. I get 40 minus 14, and that's equal to 26. But this is the entire thing. VT is half the diagonal, so divide this by 2, and I get 13. That would be my final answer. This is VT. Number 8 says JM is equal to x plus 17. So JM is half the diagonal, x plus 17, and K is the other half. The diagonal is 5x minus 23. It says find JL, the entire thing. Okay, so let's go ahead and do the same approach that we did here. Let's avoid any manipulation like we did here, because we might end up working with fractions. So we have one half a diagonal and another half a diagonal. We have a rectangle, they're equal, so I can say x plus 17 is equal to 5x minus 23. Okay, and let's solve for x. I get, I'm gonna do this faster. Okay, so I get 4x is equal to 40. Then I get that x is equal to 10. Now it says find JL, so let's plug into JM right here. JM is equal to 10 plus 17. That's when I plug in x, and I get 27. Now that's only JM, half of it. So if I multiply this by 2, I get JL, the whole thing. So 27 times 2, JL is equal to 54. That's 27 times 2. And I'm done. Number 9 says VW here is 9x minus 11. SU, the entire diagonal, is 16x minus 12. Find WT. WT is the other half diagonal there. So I can take, if the entire thing is 16x minus 12, SU, I can do, and VW is half, I can multiply this one by 2 to get the entire diagonal, which is this one here. So I can do 2 times 9x minus 11 is equal to 16x minus 12, the entire thing. I get 18x minus 22. I distribute the 2. That's equal to 16x minus 12, and then it becomes solving for x. So I get 2x, and I'm skipping a step here. I'm subtracting the x's. I get 2x. Then I add 22 to both sides. This one, again, plus 22 to negative 12. I'm going to get positive 10. X is equal to 5. Now it says find WT. WT is this one. Let's plug into VW. VW is 9 times 5 minus 11, and I get 45 minus 11, and that's equal to 34. WT is the other half of this diagonal, so this one's 34, and again we know that the diagonals are equal, so this one is equal to this one, so then WT is also 54. Oops, not 54, 34. Number 10, it says find the measure of angle BCE. BCE is this one here, and then this one here is 11x minus 3. This one, there's an easier approach than the one they want us to use here, because they give us this angle here. We know, let me use red, we know this is a right angle. Okay, so we can say, let's see here, we can say 11x minus 13 plus this missing angle here would give me 90 degrees, or let's see, maybe the best way to go about it is to use alternate interior angles. So I apologize. Let's go ahead and use DC and AB as my two parallel lines, and then AC is my transversal. So then this angle here and this angle here are alternate interior angles. So they are equal. So 11x minus 3 is equal to 7x plus 5. And we'll come back to the red marks I made there. So that's all for x. I get 4x is equal to 8, and I get x is equal to 2. I skipped some steps, but you can go ahead and write in all your steps, and you'll see that x is equal to 2. I plug in here, okay, because I need to find BCE, and I get 11 times 2 minus 3, 22 minus 3, and I get 19. Okay, so this angle here is 19, so that's equal to 19 degrees. This entire angle here that I've denoted here with the red box needs to be 90. So 90 minus 19 gives me this angle here. So 90 minus 19, that is equal to 71 degrees, and that's the measure of BCE. And I'm done. Number 11, find the measure of JHI. Here's JHI, and then I'm giving these two here. Okay, so Let me use red. This is 90 degrees. Okay, they give me both parts of they give me both angles here, and then together they make them 90 degrees. So let's use that expression. So I have 3x minus 2, that's that one. Oops, 3x plus 2. So this angle plus this angle plus 12x minus 17 is equal to 90 degrees. Combine like terms, I get 15x minus 15 is equal to 90 degrees. And if you're not sure what I did there, I combined this one and this one, that's 15x, and then I combined this one and that one, and I get negative 15. So let's solve for x. I get 15x is equal to 105, and then when I divide here, I get 105 divided by 15, I get 7. So x is equal to 7. And again, I'm finding JHI, so it's only part of it. You can treat it as we could look at it as alternate interior angles. If I treat these two as my parallel lines, and then this one here is my transversal, so then this angle here, let me use let's use red. This angle here, okay, is equal to or alternate interior angle with this angle here, so they're equal. Now that I found x, let's plug into this one, and then if this one is equal to this one, then they're the same. Okay, so 3 times 7 plus 2, I get 21 plus 2, and I get 23 degrees. So then the measure of angle JHI is equal to 23 degrees, because this one's the same. Last two, I have find the measure of XZY. Here's X, here's Z, here's Y. Let's see, Ike corner, this one's 90 degrees. Okay, and I'm going to trace this entire triangle here. We know that the measure inside a triangle is going to be 180 degrees. We know this one's 90, and then with these two are set up by this expression, so maybe we could use that to find our what x is. So 5x minus 8, that's that angle, whoops, this angle, plus this angle, plus x plus 20 plus 90 is equal to 180 degrees. Let's combine like terms. So I'm going to use blue for my x's. This one, that's it. Then I have three constants. This one, negative 8, 20, and 90. I get 6x, those are my blue ones, and then my green I get 102, so plus 102, that's equal to 180 degrees. Subtract 102 from both sides, I get that 6x is equal to let me see, 80, 78. Then I do 78 divided by 6, and I get 13. So x is equal to 13. And again, I'm finding the measure of x, y, z. X, y, z. If I go ahead and if I go ahead and plug this into both of these, I can find the measure of these two, and then let me see, x, y, z. Measure of x, y, z is x, y, z. That's the entire corner. So I can, let's see. Oh, I see. Okay, It's not XYZ, it's XZY. XZY. So my mistake, you plug into this one. Now that I found X, I can just plug it in here, and then that gives me the answer. So X is ZY, plug in 13 here, and I get 13. I get 13 plus 20. So then the measure of XZW, I keep saying it wrong for some reason, I apologize, is 33 degrees. And I apologize for completely messing up the name of that angle, the label of that angle. Last one says solve for X. I have X, so yeah, I just have X here. I'm gonna use, let's see, I can use properties of isosceles triangles, just based on this idea we've been seeing repeatedly in the previous examples. I know that all these four measures here are equal, therefore the opposite angles going to this one and then this one going to this one are also equal. So if let's see, if this one is 5x plus 17, this one is also 5x plus 17 because it's a base angle to this isosceles triangle here. Okay, and then I'm going to use this 134 to be able to find the vertex angle DHG, this one here. So using blue, I can see this is a straight line. Okay, so then they need to add up, oops, they need to add up to 180 degrees. So 180 minus 134, I get 46 degrees. So let me see. Okay, this one is 46 degrees. I don't know if you can see it. Okay, so then 46 plus 5x plus 7 plus 5x plus 7, they all add up to 180 degrees. So 5x 7 plus 5x plus 7 plus 46 equals 180 degrees. Combine like terms, my x's, my constants, I get 10x. Let me see, 7 plus 7 is 14 plus 46, I get 60. That's equal to 180 degrees. Subtract 60 from both sides, I get 10x is equal to 120 degrees. Divide by 10 and I get that x is equal to 12. And I'm done because it just says solve for x. And that wraps up concept 37.